Hello, welcome to Byte Buster. Today I'm going to talk about NMOS and PMOS transistors. NMOS and PMOS are the two basic components of CMOS technology, and they are widely used in modern digital circuits, microprocessors, and integrated circuits. So, let's look at what NMOS and PMOS are, how they work, and why they are important. Now let's look at the appearance and basic differences between NMOS and PMOS transistors. In an NMOS transistor, the current flow usually occurs from drain to source. In a PMOS transistor, the current flows from source to drain. Another important feature is that the PMOS symbol has a small dot or bubble near the gate terminal. This that is used as an identifying mark for PMOS. The NMOS symbol does not have such a dot. NMOS is an N-channel MOSFET, where the main charge carriers are electrons. PMOS is a P-channel MOSFET, where the main charge carriers are holes. Because of this, NMOS and PMOS work in opposite ways and are used as complementary devices in CMOS circuits. Now let's see why NMOS and PMOS are used. NMOS and PMOS transistors are used together to build CMOS circuits. In CMOS technology, the NMOS transistor is used to pull the output down to logic 0, low, while the PMOS transistor is used to pull the output up to logic 1, high. By using both together, we get low power consumption, faster operation, and more reliable logic outputs. Because of this, most modern computers, mobile phones, microprocessors, and digital circuits are based on CMOS technology. Now, let's see how an NMOS transistor works. The NMOS turns on, or OFF, depending on the signal applied to the gate terminal. First, let's consider the gate input A equals 0. In this case, the NMOS transistor is in the OFF state. So there is no connection between drain and source, and no current flows. It behaves like an open circuit. Now, let's consider the gate input A equals 1. In this case, the NMOS transistor turns on. So a connection is created between drain and source, and current can flow. It behaves like a closed switch or a short circuit. Simply put, just like a bulb turns on when a switch is closed, an NMOS transistor turns on when it receives a high, logic 1, signal. When it receives a low, logic 0 signal, it turns off and blocks the current flow. Now let's look at how a PMOS transistor works. Good. Now let's look at the PMOS transistor. Remember, in PMOS the current flows from source to drain. Keep this in mind while understanding its operation. In NMOS, we saw that when A equals 1, the transistor turns on and current flows. But in PMOS, it is the opposite. PMOS works in the reverse way compared to NMOS. As shown in the diagram, when A equals 0, the PMOS transistor turns on. So a connection is created between source and drain and current flows. But when A equals 1, the PMOS transistor turns off and no current flows. Simply put, using the same bulb and switch example in PMOS, when the switch is on, the bulb turns off, and when the switch is off, the bulb turns on. That means a PMOS transistor turns on with a low, logic 0, signal and turns off with a high, logic 1 signal. So the main difference between NMOS and PMOS is that NMOS turns on with a high signal, while PMOS turns on with a low signal. Here is your script in simple presentation English. All these concepts can be understood very easily using these diagrams. The working of NMOS and PMOS is not difficult to understand. If you remember the basic idea that an NMOS turns on with a high signal and a PMOS turns on with a low signal, you can easily understand how they work. Now let's see how NMOS and PMOS are used together to build a CMOS circuit. CMOS, complementary metal oxide semiconductor. CMOS, NMOS, PMOS transistor, technology, CMOS inverter. Inverter, logical not gate. Input 1, output 0. Input 0, output 1. PMOS, NMOS transistor. VIN, input voltage. VOUT, output voltage. VIN, signal NMOS, PMOS. VIN equals 0. PMOS, low signal, on. NMOS, off. VDD, VOUT. VOUT, ground. VDD, voltage, VOUT. VOUT equals 1. VIN equals 1. NMOS on, PMOS off, VDD Vout, Vout ground, Vout ground, Vout equals 0. Input 0, output 1. Input 1, output 0. Circuit CMOS inverter, not gate. NMOS, PMOS. CMOS inverter. Vin equals 0, PMOS on. VDD Vout connection close, conducting path. VD voltage Vout. NMOS OFF Vout ground path open connection. Vout equals 1. Vin equals 1, NMOS on. Vout ground connection close. Vout ground 0, PMOS OFF VD Vout path open. Simply put, in a CMOS inverter, when one transistor is on, the other one is always OFF. Because of this, the output always goes to stable state, either VDD logic 1 or ground logic 0.